What we are projecting here is really cutting-edge technology and how we believe this can be used and will be used in the future. Working with different consultants, contractors, to develop a platform that everybody can collaborate on. Looking at construction as a much more holistic kind of thing, not as just constructing the building, but also looking at the kind of lifespan of a building.
I think what's useful about having a digital DED class is a lot of firms are moving towards taking digital directly to the field. We already have that expertise, so we really have a kind of three-dimensional understanding of every component that goes into how this building would actually be constructed.
Throughout the semester, the dialogue has worked really well to use animation to communicate the design and the detail and the composition.
So we have been teaching this class for, I think, almost a decade now, and we really changed to an all-digital format. One thing that has changed by using the tablets and marking things up digitally is the dynamic between the students and the faculty is a lot more interactive. We are looking at multiple screens usually that are displaying multiple realities, where students on one screen show the overall building and its structural system, then zoom in onto a detail and then show a video of how a part like this would be fabricated in real life. So combining all those three realities into one frame and understanding that those three things are related is really important. So we screen capture those things, we mark them up, we sketch on top, students sketch on top of those sketches. So it's a very kind of fluid and very kind of interactive process of how faculty and students are collaborating on developing these projects.
One of the things that's interesting in this year's adoption of the digital tools is we can start to see the students think about how air flows. Similarly, the tools have developed such that you see things like solar radiation and how buildings respond to sunlight. Students start to look at a tool called mass motion, how occupants are going to evacuate a building during an emergency situation. The students have really adopted these principles way faster than I expected.
So when I sit down with the students, I'm not trying to teach them how to be a structural engineer. I'm trying to give them context for having a discussion in the future with their structural engineer and understanding what they're going to be concerned with and being able to address that through design solutions.
It really is like working in a small office, really giving everyone a task and kind of understanding the project as a whole. We can actually kind of direct and have a more one-on-one relationship between the architect and the contractor and the structural engineer, and that way we can start to understand their process and also bring some of our process into their practice as well.
Adding an element of time to it really kind of grounds it in terms of construction and sequencing and thinking about how the entire system is put together and how that system fits into other systems like structural systems.
In this class, we actually need to do research how this project can go through the construction process, what material we're going to use, and how the final project's going to look in the future.
When we speak about the life cycle of the building, we also have to consider the fourth or the fifth dimension, which is the time, how the building is aging, and not only this, but how the building is actually assembled. The animations which we are doing in the class is actually showing what is the sequence of construction and how the construction and how the cost of the building and the life cycle is changing when you change one of these different components.
SCI-Arc really is pushing the boundaries. This class is actually demonstrating how digital will be used to build in the future.